Okay, everyone, let's continue our conversation. Okay, so we're talking about the SI unit for temperature, which is Kelvin. Okay, and I want to give you an idea of what we mean by Kelvin. So Kelvin was, we came to Kelvin when we were talking about and realizing absolute zero. Okay, so what absolute zero is, so temperature is just an energy which causes vibrations of atoms and molecules. Okay, so everything that's above 0 degrees Kelvin is vibrating and moving, and then as we get it colder and colder, they slow down and slow down, and the point that they're no longer moving, that we've taken away that energy, that would be absolute zero, or 0 degrees Kelvin. Now, this conversion here, 0 degrees Kelvin is equivalent to a negative 273.15 degrees Celsius. So this is extremely cold. Now, to give you some context, something you might be a little more familiar with, this is about 460 degrees, negative 460 degrees Fahrenheit. This is extremely cold. Okay, so that's what a Kelvin is. 0 Kelvin is absolute zero. Now, when we make our conversion factors with length, we need to start memorizing these prefixes and what they mean. So the first one is 1 meter. You will need to know and have memorized that that contains 100 centimeters. And so 1 centimeter would be 1/100th of a meter, or 0.01 meters. Okay, those are our ratios, those are our conversion factors. So let's just look at this first one together. If I am 191 centimeters tall, how tall am I in meters? Well, I know that every single meter contains 100 centimeters, so I have 191, so that'd be 1.91 meters. Okay? All right, so now let's look at this line that we have using our centimeter ruler. How long is the red line in centimeters? Well, let's see, we have 2, and then we have 0.1, 2, 3, 4, 5, 6, 7, almost 8. So 2.7, we'll estimate that it's 8/10 of the way to the next calibration mark there. And so that would be 27.8 millimeters. And then if we rounded that to the nearest centimeter, that would be 3 centimeters. All right, again, this is what needs to be memorized. These conversion factors, you will have to know them for the exam. Here's another one that it's going to be important to know, that 10 millimeters is within 1 centimeter. They're equivalent. All right, so with that in mind, 1 meter or 105 centimeters. Well, 1 meter is 100 centimeters, so the larger one would be the 105. And 12 centimeters or 102 millimeters. Well, for every single one of those centimeters, we have 10 millimeters. And so this would be 120 centimeters, 120 millimeters, so that one is greater. 4 kilometers or 4,400 kilometers. Well, every single one of those kilometers contains 1,000. So this would be 4,000 kilometers, 4,000 meters, I mean, and so that's our greater value there. And then 1,200 millimeters or 1 meter. 1 meter contains 1,000 millimeters, so that would be our larger value. Okay. Now, what is the difference between mass and weight? The mass of the object doesn't change with the location of the object. Whether we're on Earth, on the moon, or free floating out in space, that object's going to have the same mass, but its weight's going to be different. its weight on Earth is greater than its weight on the moon, and it doesn't have any weight, it's weightless, free floating out in space. Now, the reason behind this is because the only thing that weight is that gravitational interaction between the object and the Earth, or the object and the moon. Any two items that have mass have a gravitational attraction. Okay? So that's the difference between the two. Now, if I weigh 96 kilograms, how many grams do I weigh? Well, every single one of those kilograms contains 1,000 grams, so that would be 96,000. The ratio that we're going to need to know from grams to kilograms, well, 1 kilogram, 1 big kilogram contains 1,000 grams. Okay? And then what is the ratio? Again, now we have this small base unit, and we're comparing it to a large kilogram. Well, it only would be 1/1000th of a kilogram. Okay, go ahead, give those two a try, and we'll keep going. All right, let's jump back to volume for a minute. We already talked through these conversion factors, okay, so it's important to remember that 1 liter contains 1,000 tiny milliliters, and 1 milliliter would only be 1/1000th of a liter, and 1 milliliter is equivalent, or the same thing, as a cubic centimeter. Okay, so 1 liter, or 1,500 milliliters, 1 liter is the same thing as 1,000 milliliters, so this one's larger. 2,000 milliliters, or 1.2 liters. Well, 2,000 milliliters is the same as 2 liters, so that one's greater. At 12 milliliters, or 12 cubic centimeters, they're the same, right? A milliliter is the same as a cubic centimeter, so those are equivalent. One's not larger than the other. All right, 2 ways of looking at volume. First, liquid volume, we'd use a graduated cylinder and we can make those measurements. Now, the most important idea here is that you need to be measuring from the bottom of the meniscus, and the meniscus is that bowl shape that the liquid creates within a container. So when I look at my graduated cylinder here in my notes, we see that we kind of have this this rounded shape here, and that is called the meniscus. Whenever you make measurements, it's really important that you measure from the bottom of the meniscus and not at the higher points on the edges there. Okay, so when I look at this, it'd be 43 milliliters. Now, geometrically, we can solve for volume. If it's a cube or a rectangle, then we can do base times by width times by height. So if I take 10 centimeters, I multiply that by 8 centimeters, multiply that by 9 centimeters, then I end with 720, but 720 what? What's my units? Well, I'm multiplying, so the units will multiply as well. So it's going to be centimeters times by centimeters times by centimeters, or cubic centimeters. The other way to measure volume of an object, usually an irregularly shaped object, is through water displacement. So if I have this graduated cylinder and I'm reading the bottom of the meniscus here, so I'm at 200 milliliters, and then I add my irregularly shaped object, and it jumps up to 265, I think is what I counted from this image. Milliliters or cubic centimeters, right? Same thing. It was displaced by 65 cubic centimeters, so that must be the volume of the object. Okay, so that's our notes for the day. Please let me know if you have any questions. Feel free to email me or come talk to me before or after school.